Was you good on that one? Okay. So let's take a look at the next example. Would be number 4. So in this one, if I have x equal to negative 3y minus 2. Oh, I'm sorry. I think this is I'm reading it wrong. Let's do it correctly. This one looks like is x minus 3y is equal to 2. X is equal to 6 plus 3y. Okay, what would be the best way to handle this? What method? Anyone? Addition method, substitution method?
Yeah, there's the addition.
Anybody?
Addition method.
I'll go for subtraction.
I like addition method. If I move, yeah, if I take the second equation here, this one here, and subtract 3y from both sides of the equation here, then I would get x minus 3y is equal to 6. So this one here, the second equation becomes x minus 3y is equal to 6. I'm just going to make it look the same. X minus 3y is equal to 2. Now, just by looking at this, somebody can tell me, is there can it just be possible? Is there a solution for that? X minus 3y is equal to 2. X minus 3y is equal to 6. Is that possible that x minus 3y would be equal to 6 at the same time x minus 3y would be equal to 6?
No, it's not.
Is this possible? Not even possible, right? Because it means these two lines are parallel. So that means these lines are parallel. In other words, if you solve this, and if I write this, if I solve this for y, let's do it that way, that would be fun. If I solve for y, both of these, the first one would becomes minus 3y is equal to minus x plus 2 if I subtract x from both sides of the equation. If I divide each term by negative 3, so that would become positive 1 over 3x minus 2/3. If I solve this for y, then I would get, divide both sides, you get 1 plus 1/3. X minus 6 over 3. So you see the coefficient of x becomes same number. It means the slope is the same. The slope is 1/3. Slope here would be 1/3. That's just another way to look at it. If the slope is the same, it means they're either parallel line or they're the same line. Obviously, they're not the same line because their equation is different. They're not the same line. So it must be parallel line if the slopes are the same. When there's a parallel line, it means there's no solution. It means it's inconsistent. Inconsistent is no solution. Consistent is there's a solution. Will you get that? So when you find two lines, you find out they're parallel. That means they are no solution.
Excuse me, I have a question. Do you think you could give us an example of a
Sure.
independent equation? I mean, for the result? Sure.
Sure. I can give you that one, right. So let's just make sure we understand this. This is another way to solve this. If I actually solve this by substitution method, you get this kind of solution. 6 is equal to 2. That means they're parallel. So you wanted to see a solution that are independent. The example for independent, is that what you're asking? Yes?
Yes, it's that.
Okay. Dependent dependent means they're the line right on top of each other. This would be example with line 1 and line 2 right at the top of each other. This is a dependent. Independent would be either you have two parallel lines or two lines that intercept at some point. That would be independent. In this case, you could get a solution or get no solution. Does that make sense? So dependent, independent. Dependent is their same exact line. Independent means they're independent of each other, those lines. They're not the same line.
I understand that. But I mean, we have an example, real example, like with equations and all that, and all the procedure in order to get that answer.
Oh, sure. Right. Sure. Right. Okay. It's very simple to make examples. Like in this case, I can give you a very simple example. If I have x plus y is equal to 2, x plus y is equal to 2, because they're the same line. Okay, this would be the example. Let me grab it here. Let me delete it from there. That's not a good place to put it. Okay, let's put them down here. This would be x plus y is equal to 2, x plus y is equal to 2, because it's an exact line. That would be one example of dependent. Or another example, 2x plus y is equal to 3, 2x plus y is equal to 3. As long as you detect they're the same line, that would be dependent. Do you follow that so far?
Yes. Okay.
Okay. Independent, like this would be about x plus, let's turn off your mic for a second, please, so I don't get the echo. X plus y is equal to 2, x plus y is equal to 3. Now, these two lines are parallel because the slope is the same, but they're not the same line. See, the slope of these are the same too. The slope for dependent or same line would be the same. Slope is the same. And here, the slope would be the same. Slope same as well. But however, they're different line. So another example here we're going to make would be 2x plus 1, y is equal to 1, 2x plus y is equal to 2. Again, these two have the same slope. They're not the same line, but they have the same slope. These are all parallel lines. So these are all another example for being independent, but they're parallel, there's no solution. Now, any other two lines that, like x plus y is equal to 7, or 2x minus 4y is equal to 2. See, if you look at the slope of these two lines, they're different. So it means they're going to intercept at some point. They're all independent. That's another example of independent. So let's make it in the y is equal to mx b plus y is equal to mx plus b form. Let me give you a couple examples like that. If I have y is equal to 2x plus 5, y is equal to 5x plus 1, okay? So this would be two lines that intercept at some point like that, and they're also independent. The only time that are dependent would be if they're the same exact line, and that we can easily detect that because it turns out to be the same equation. Does that make sense so far?
Yes, now it makes sense.
Okay. So if I look at those examples that I had, so if you look at this example here, we just earlier did, this turns out to be the, look at the equation, x minus 3y is equal to 2, x is equal to 6 plus 3y. Okay? So if you look carefully here, if I make it look the same format, if I just like move this 3y to the other side, x minus 3y is equal to 6, x minus 3y is equal to 2. So you see these two lines have the same slope, but they're not the same line, so they must be parallel. So if they're parallel, means they're independent, but when there's no solution, they call it the system is inconsistent. The only time the system is inconsistent when there's no solution. Other than that, it's consistent. If they're the same line, if the lines are on the top of each other, the same line, or there are two lines that are intersect at some point, they're consistent because you get a solution. Either you get one solution or infinite limit.
So we will basically say that if the lines are...
So the only time the system is inconsistent is when there's no solution. In other words, if they're parallel.
Okay, that's exactly what I meant. When they're parallel, it's because it's inconsistent.
Yes.
Okay, got it. Thank you.
If the lines are parallel, they're inconsistent. Other than that, they're consistent.
Okay, I got it. Thank you.
That's a good way to remember it. Very good. Good job.